The content in this video is from my free hands-on course on LangGraph. In this course, you will get practical step-by-step guidance on building with the LangGraph framework. You can join it by visiting my portal courses.pragmaticpaths.com. Check the description for the link and more details. Now let's see a LangGraph workflow in action. In this video, we'll start with the core concepts of workflows and agents. Then I will break down the key LangGraph APIs you need to know. Finally, we'll bring it all together by building and running a real LangGraph workflow live. A static or traditional workflow follows a static predefined sequence of tasks with a deterministic flow of control to produce a final output. As depicted in this illustration, the sequence of execution of tasks A, B, and C is fixed. The flow is said to be deterministic. In other words, for a given input, you can easily predict the flow of control. On the other hand, an intelligent workflow uses an LLM as a reasoning engine to dynamically determine the sequence of tasks. A reasoning LLM decides on the service or the task to be executed, which means that as a developer, you do not hard code the sequence of execution. This is the core idea of agents, in which workflow is implemented in the form of agentic loop. The agent passes the context to the reasoning LLM that then returns the next service or set of services to be executed. Agent executes the services and updates the context with the response received from the services, and then again invokes the reasoning LLM. The LLM may respond back with additional services to be executed, or it may return the result which the agent then returns as the final response. The sequence in which the services are executed is non-deterministic, as it is planned by the LLM at runtime. Workflow orchestration is an approach where a centralized orchestrator executes and manages a sequence of tasks or services. The orchestrator maintains full awareness of the workflow state and all the available services, while the services remain unaware of the central orchestrator. Execution begins by invoking the orchestrator, which coordinates the entire process and ultimately delivers the final output. LangGraph is an orchestration framework that offers tools for building workflows. Using LangGraph, with just a few lines of code, you can easily build static as well as agentic workflows. LangGraph offers two ways to create workflows. You can use the Graph API or the Functional API. The basic idea behind the LangGraph Graph API is that workflows and agents can be modeled as graphs. Here is an example of how a simple static workflow as a graph look like. This workflow executes two tasks in sequence. This is an example of agentic workflow in which the agent task uses a reasoning model to decide on the tools to be executed. To create the workflow, you will use the Graph API to set up the workflow as a graph. Then you need to compile the graph. This compiled version of the graph can be visualized and it can be executed with invoke or stream APIs. A graph can be stateless or stateful. In a stateless graph, nodes in the graph do not share state information. Every node defines its own input and output structure, allowing you to chain together different tools, LLMs, or logic without enforcing rigid data formats across the entire system. Stateless graph is characterized by decoupled nodes. Each node processes data in its own preferred format. In this illustration, an LLM may expect a string and output a JSON. This output from the LLM is flowing into a tool which is then generating a JSON output. A stateless graph has no shared memory, which means that data flows through the edges and nodes don't implicitly access prior states unless you pass them explicitly. And the third is there are explicit transitions, which means that the nodes return their output and the graph routes them to the next step based on your logic. In a stateful graph, there is a shared state object that nodes can read and modify. The state for the graph has a defined schema, so its structure is clear upfront. Each node in the graph can read and modify this shared state as it runs. When the graph finishes executing, the output you get is just the final state after all the updates. To build a stateful graph, you will first need to define the state schema. There is no LangGraph specific schema class. Instead, you will create a schema class that is either a type dictionary for basic type hints or a pydantic base model if you need to define a complex state schema. This gives you complete control over how you structure your state. Your schema is really just a collection of keys with their types. These can be simple types like integers or strings, or they can be more complex types like lists and dictionaries. It is totally up to you how you design the schema. When the nodes interact with the shared state, they modify the state attribute values. Nodes can override the attribute value. Nodes can append to a list attribute instead of overwriting. For example, a conversation history attribute will hold the list of messages, and nodes can append messages to this list. A node may apply any kind of custom processing logic to the state attributes. In this hands-on lesson, you will learn step by step how to set up a state schema class and construct a stateful graph. Details for this exercise are available under the section Agentic Workflows. The state schema for this graph will consist of two attributes: messages, which is a list of strings, and total words, which keeps track of the total words across all messages in the list. The graph will have two nodes. Add node will generate a dummy message and then add it to the list of messages maintained in the shared state of the graph. Increment word count will check the length of the last message and add it to the total words in the shared state. I suggest that you follow along, and to do that, create a notebook at this location. Now we are ready to roll forward, and next I'll show you step by step how to set up a stateful graph. The solution is available to you under the LangGraph folder in the project repository. Let's start by creating a class state basic. This will hold the schema for our graph. State basic is of type typed dictionary. It has two attributes: messages, which is of type list of string, and total words, which is of type int. Let me fix this. It will be a column. We need to import typed dictionary and list from the typing package. So this defines the state schema for our graph. Next, I'm going to create a function add message, which will receive the state as argument, and it'll return a dictionary. Let's create a dummy message here. Message equal to this is a dummy message when total words is equal to, and now we'll access the total words attribute from the state variable total words. So this is going to create a dummy message. Now we need to create the updated value for the messages attribute. So we'll create a new variable messages equal to get the current value of messages from the state variable and add the new message that we have created. Now we need to return this updated value in a dictionary. So messages colon messages, and this will override the value of the messages attribute in the shared state. Next we define the node function increment word count. I'll just copy this here. This node will also receive the state and return a dictionary. This function needs to get the length of the last message and add it to the total words. So to do that, I'm going to create a new variable last message equal to state message and -1. So this will get us the last message. And then we'll do total words equal to get the current total words and then add the length of last message. And now we will return the updated value for the total words in a dictionary. So total words, just provide the total words that we have calculated, and at this time our two nodes are created. Next we need to create the graph, and to create the graph we will say workflow stateful equal to state graph, and we'll pass it the state basic, which is the schema. This will create the graph builder, and let me just import it from LangGraph import state graph, and since we'll also be using start and end, let's import that too. I need to do it from the graph package. So now we're ready to add the nodes. So workflow underscore stateful dot add node, and this is going to be similar to what we did for the stateless graph. So let me just pause the video and type it out. So the two nodes are now added. Let's add the edges now, and for the edges we will start by adding the add message. Then we will add an edge from the add message to the increment word count node, and then from the increment word count node we will point to the end. So this will create our graph. Let's compile it. Workflow underscore stateful dot compile. Hold this compile graph in the new variable workflow stateful compiled. Let's display this graph. So here we are getting the graph from workflow stateful compiled. Let's just run it, and I got an error, and that's because I missed out the square bracket here. And now we are good, and here is our graph. Let's invoke this graph. To invoke the graph, I'm going to pass in the total words as 0 and an empty list of messages. Run it again, and I received another error which indicates a bad key name. So let me fix this. Here, instead of saying messages, I had said message, So let's do that and now run it. So here is the final output. Now what I can do is I can just get the response from here and then call this graph again, and instead of passing this dictionary, I'll pass in the response and then print the response. This is to show you that the state variables are getting updated. So let's run it. And now as you can see, there are two messages, message number 1, message number 2, and here are the total words. So in this demo, we created a very simple graph in which the nodes are overwriting the state attributes, which are messages and total words here. In the next hands-on exercise, you will learn how to use annotated types. Happy learning, and I'll see you in the next video.